Hi, Caleb. So just in case you're wondering if you've come to a confused art class, so we are trying to guess, this is a world landmark, and we're trying to guess what building this is. And so this is in a new series of introductory drawings by me. So can you guess? So you are right, Alzan. That is my attempt.
Yes.
At the Statue of Liberty. So I want to know what building. I'll give it a little pedestal to. Oh, yeah. So now, what building is this? And Caleb, what do you think? What else is nearby? Okay, yeah, I'll just wait. I think it's reached the best I can do. And then also, if anybody else is watching right now, we have these warm-up questions, and I'm just going to call this question 1, question 2, and question 3. And we are doing exam prep warm-up, and the session today is on exam preparation. Cool. Okay, Elzan, do you want to have a guess?
Is it something to do with like 7-Eleven? Like, is it one of the buildings that fell down, perhaps?
Okay, it's in the same part. Yes, it's in the same neighborhood. It's in exactly the same neighborhood.
In the same neighborhood.
Yeah, it's in Manhattan. So it's in yeah.
Your Peter.
Okay, well, I'm not going to give it away. I'll give it away later. You have to stay to the end of the show, but
can I Google it?
You can, then you don't get the credit. Okay. Have we got everyone's a bit okay? Well, we can continue having fun while we wait. And then Caleb, can you just give us a thumbs up so we know that everything is actually working? Because I'm worried that I've scared away all the students with my drawings. Okay. Yes. Good to know. Thank you, Caleb.
Great stuff. Caleb, I'd love to hear, when are you writing your maths exams? Have you written it already, or when is it coming up for you? You can either unmute yourself or just put it in the chat, whatever suits you best.
Okay, I'm going to draw one additional thing here. This will help.
So Caleb says he's writing his second paper on the 1st of December.
Oh, so still quite a long time. Yeah.
There is still time.
So Caleb, yeah. So Caleb, one of the things we decided is that obviously as we get to the end of the year, we want to adapt the lessons to be as useful as possible to the students who are here. So I obviously have been a teacher for a long time, and I'm going to try and do what I think is the most helpful. But if you have specific questions, you can send them in or send us a link, or so we're quite adaptable and flexible. So please, if you've got questions, do feel free to share them, and we can incorporate them into the lesson. Okay. Sorry, Elzan, yeah.
No, I was just going to ask how his first paper went.
Oh, yes. Yeah, exactly. How did the first paper go, Caleb? I think we'll probably start soon anyway now. It doesn't matter how many. Sometimes there's people on the live stream that we can't always see. So I think we will do a normal lesson, but we'll just wait. Caleb, how did the first paper go? Not all of it. Okay. So we need to be extra. Today, I'm going to share my knowledge from, 14 years of teaching this, and I'm going to give you all the inside knowledge, and we're gonna get you there. Okay. And please feel free to ask questions as we go. I'm happy to adapt the pace of the lesson to suit you. Okay. Asamakle, welcome. Okay. So in the interim, guys, what I really want you to do is, I'm just going to actually show you why we're doing these warm-up questions. So the focus for today is going to be on paper 2, and a good strategy is always trying to get, the most marks for the time you spend. So we're going to focus on analytical geometry and trigonometry today because they wake up almost 2/3 of paper 2. And I think that it's an efficient strategy to start there. Now, in the previous lesson, we focused on functions and graphs. And then before that, we focused on general algebra. So you can see I'm trying to be efficient in that I only have a limited amount of time, like when you're writing an exam. How do I spend my time that I get the best value for money, to use an advert idea? And when we do these questions, you'll notice that I'm going to focus you a lot of the time around knowledge questions and routine procedures, because these form the basis of everything. And generally, you need to get these right first before you can get these right. And so a lot of the times, if students spend time on this question over here before they've got all the marks over here, that's not a good strategy. Okay, so I'm going to try and reinforce that as we go. Now, this is just for me to gauge how much knowledge you have of the analytical geometry. So I'd like you to do these 3 questions and then put the answer in the chat. Okay, so question 1, question 2, question 3, and give me a multiple choice. I will give this A and B, give that A, B, C and D, and then that. And if you need tips, jump online or use the chat. Alzon, any more general comments or questions that you want to make?
Nothing from my side so far, just enjoy. I see that we are live on YouTube. So hi to all the learners out there. We hope that you enjoy the lesson and we'd love to get some feedback. So put your answers and your questions on the chat and we'll be more than happy to assist you from there.
Cool.
Awesome. Thanks, Peter.
Okay, so for this first question, I'll give you a hint. I'll give you a picture. Consider a straight line and consider if these 3 points are on the line, we would say they're collinear. Now, if you have 3 points and 2 of them are on the line and 1 is off the line, those are not collinear. Now, if you were checking whether something is collinear, what you would actually check is that the gradient between 2 pairs of the points is the same. Can you see how the gradient, let's say the gradient here, and okay, maybe I'm drawing this a bit small, but basically what I'm trying to show you is that the gradient from here to here is the same as the gradient from here to here if you're on the same line. But if you're not on the same line, the gradient from here to here is not the same as the gradient from here to here. So that's my hint. I don't know if I confused you more than I helped you, but yeah. So see if that can help you. So I would start by taking these points and working out the gradients between, say, 2 of them, and then that one and that one. For this one, you need something called the distance formula. And the distance formula looks like this, where inside it is the change in X and the change in Y. And then the midpoint formula is just x1 plus x2 over 2 and y1 plus y2 over 2. So I'd like you to try and do those. And then once you've done them, if you could put them in the chat, please. And I'll give you a little bit more time because I will speed this lesson up a lot if I see you guys are comfortable with this. But if you haven't mastered this, this is what I would call the knowledge and routine procedures part. You have to bank these marks in your exam. They should be the first marks that you kind of clear off. Okay, so I'll even do some of that working as we go. So if we look at the first one, I'm going to say 0 minus 0 on top. And then I'm going to have, so basically that's this one minus this one. And then I'm going to go 0 minus minus 3 over here. So that would be question number 1. And then I'm going to go 2 minus 0 for this one. And then I'm going to go 0 minus 0. Okay, we have a problem here. Well, not a problem, but on the top it's 0, which means that everything over here is 0. Over here, this is 2, but this is 0. And we're not allowed to divide by 0. And so, in fact, these are going to be, this is going to be undefined. So I'm going to close my door. There's a bit of a noise coming through. There's a bit of a noisy bird outside. And so in this first question, not only are these not collinear, the first one is a flat graph. It's just got a gradient of 0. And the other one is standing vertically up. So they're most, definitely not collinear. And so the answer would be B. Oh, sorry. Yeah, the answer would be B for that. Okay, any questions about that? So I found the gradient of these two graphs, and because the one was 0 and the other one was undefined, if they were both the same, then they would have been collinear. Okay, so I'm going to move on from that one. Any questions in the chat or the comment? I know it looks like my screen looks a bit like a Christmas tree, but we will try and strike a balance between usability and interestingness. So second question, the distance between these 2 points. Okay, so what I'm going to say for the first one is the distance between the x's, or the difference between the x's, 0 minus 0 is 0. And then the distance between here, minus 2 minus 6 is going to be minus 8. And so now this is going to be 64 because 0 squared is 0. Minus 8 squared is positive 64, which means that the square root would be 8. And so the answer would be C. And then to find the midpoint of the line segments, I simply just go minus 2 plus 6. So minus 2 plus 6 divided by 2. And then I also go, for the other one, I go 4 plus 10 divided by 2. And so we get, for the final answer, so minus 2 plus 6 is 4. 4 divided by 2 is 2. 4 plus 10 is 14, and then it's 2, 7. So the answer would be here. Okay, any questions or comments before I move on? Okay, anybody want to guess my drawing? So this drawing is, anybody want to guess in the chat? I don't want to give it away. I was trying to draw what's called the Empire State Building. Okay, and I actually went there once in 2002. Can you believe it? But that's a story for another time. So let's move on. Actually, before I move on to this exam question, are there any comments or questions? Okay. So this is an exam question for analytical geometry, and you can kind of see why I built up to this. Now, when you see these questions, often it looks very cluttered, and the clutter kind of overwhelms students sometimes. But a lot of time what's being said here in words is also in the drawing. And only very rarely do you have to take stuff from the drawing and put it, from the words and put it on the drawing. Okay, so what are the major characters in this question? Well, there's the point A. Okay, point, yes, hi.
Hi, Peter, sorry. Alzan, do you mind starting the live stream again? We're just having some issues. Thank you, sorry. Bye.
Oh, good. Welcome. Oh, hi, Antonio. I see you've joined us. So if you look at, okay, so where was it? So I was talking about the characters involved here. So point A is down here. You've got point B up here, and then you've got C over here. So if you want to find the gradient of AB, all that's going to happen, and this is what basic knowledge question. This is a knowledge question. So you might want to make sure you always do it. You're just going to go 12 minus 3 over 4 minus 5. The things that students do wrong is that they often switch the X and Y around. So sorry, this is the Y, this is the X. And so when you do it, what I do to help not kind of make sure I don't make a mistake is I always start with the Y's and I put them on top. Then there's the double negative. So we're going to get 15 and then we get over 9. So that's going to be answer number 1. And that should be 2 marks in the bag. Thanks for coming. Determine the coordinates of E. I want to know in the chat, what is special about point E? What, because it said just find it, and I want to know how, where do I even start? So can someone reply in the chat, what is special about point E? And that's going to help me. Anyone? Antonio, any ideas? So if you look at E, I think this is on the X, it's on the X axis, it's what we call the X intercept, right? And it's on the line between A and B. Now we just worked out the gradient of AB, and if we worked out the equation of the straight line, we could then work out the X intercept. Notice how this is 3 marks. So this is what I would call routine procedure. And again, you really want to put good effort into this to make sure that you get the answer and you get your sort of maximum amount of marks. So there's different ways to find the equation of the straight line. I always found that this one made the most sense, but there are other ways. So I've substituted, all straight lines have the equation y equals mx plus c, although there's other ways of writing that. You need a point on that line in order to figure out what the C is. Now, if we knew what that point was there, that would be C, but we don't. So we have to sub in one of the 2 points, and I'm going to choose 412 because it just looks easier to me. And so let me get rid of this. So if I sub in the point 412, I need to make sure that the 12 goes to this side. Let me actually use it in a different color. So 12 equals 15 over 9, and then the 4 goes here, and then plus C. So now all I need to do, and I mean, you can basically use your calculator first, but I'm just going to, 4 is just 4 over 1, so I get 60 over 9 plus C. I've just times the 4 to the top of the 15. And then if I take away 60 over 9 from both sides, I get this. So let's see what C is. 12 minus 60 divided by 9, I get 5 1/3. Okay, now I'm going to then find what the x-intercept is by making, whenever something is on the x-intercept, its y value is 0. And so because of time, I'm not going to do the working. I'm going to bring up the answer now, but I just want you to follow the procedures that I'm pointing out. Let me grab this bit. 4.1, 4.2. Okay. They actually do this in a slightly different way, but they still get the same answer as us. What are they doing? Yeah, okay. So basically, once I've got my final answer, so what do I have? I have y equals 15 over 9x plus 5 1/3. And then in order to find the x-intercept, I make y 0. Let me get rid of this. So if I make y 0, I get this. Oh, in case you're wondering why it says 5 over 3, I didn't simplify 15 over 9. So if you think about it, 15 over 9 can be, if you divide the top and bottom by 3, you would get 5 over 3. So that's equivalent in the answer. So now what's going to happen is I'm simply going to solve this equation for x, which is this thing here. And all I need to do is move the 5 1/3 to the other side and divide by 15/9. And then you should get the answer minus 16/5. Okay. So because of time, I'm not going to go, I think I've showed you the method, but are there questions in the chat? Okay, so we are then going to, and also notice that minus 16/5 is the same as minus 3 1/5. So that's this point here. Okay, so now what I'm going to do is I'm going to say, determine the size of A, round off to the nearest whole number. Now, what is, or alpha? So what is alpha? Alpha is the angle made with the positive x-axis. Now, this is what I would call a complex procedure. So if you're unsure of this, what you should do is leave this question out and find the other routine and knowledge procedure questions. Now, the bit of knowledge that you need to know about is the formula that tan of theta, or the tan of alpha, is equal to the gradient of this line. So we said the gradient was 15/9 or 5/3. If you connect that knowledge, you can then work out what alpha is by using trigonometry. So can you please get me the answer in the chat? Now, you need to use what's called the inverse trig function. So you go shift tan 15/9, and then you will get this angle over here. Okay. So I'll give you a moment to have a look at that while I get rid of this bit of working. What answer do you get for the positive alpha angle? So you go, you know that the gradient of this line is 15/9, and then you go shift tan 15/9, and this is what's called a complex procedure. I'll call it CP. Yep. What do you get for your answer of alpha? So what I get, excuse the many layers, according to this, you should get 59 degrees. Now, ignore this for now. I'll talk to you about that. This last question, okay, so we've got this is 59 degrees. Now, in the next part of the question, it's worth a lot of marks, but you don't want to spend an infinite time on it if you're struggling with the first couple of questions. All you want to do is do the basic working out that you can do, and then move on to the other knowledge and routine procedures. But just to show you what this question is asking, it says, if theta is 76 degrees, now theta has actually been referred to earlier in the question. That's why this is a harder question. ABC, so ABC, oh, there's theta up here. If ABC, or if this is 76 degrees, determine the equation of the line through A parallel to BC. So through A parallel to BC. So basically they're saying, can you figure out the equation of that line? And it's related to this line over here. Now, all I would make sure to do, even just to get some marks here, is make sure that you know the point A is involved. And then you are going to need to work out the gradient of this green line here. And because it's all one of, the relationship between them, then transfer that across to this one over here. And that's what the answer is doing here. It's working out what the gradient of that is and transferring it across. Because of time today and our focus on being efficient, I'm going to move on. So in this question, because I want to spend about half the time on this and half the time on trig. In this next question, I'm going to show you the questions you should focus on if you want to bank your marks. Even if this looks very detailed and very almost cluttered, what are the bits of kind of dry land that you can find? So I would label this first question. I would label this first question over here a knowledge question. I would label this question over here a routine procedure. Find the equation of the line. This is sort of on the border between a routine procedure and a complex procedure. And then over here, this is still calculate the length. Okay, so these relate to the earlier questions, which sometimes can make them seem a bit more complicated. It's not that you should not answer these, but I would definitely focus my attention around these questions. So I want you to have a go. Can you do for me quickly 3.1, 3.2, and 3.3? Another thing that's helpful is to use colors. So here is AC. Now, oh, the moment I say something with a C or S, Siri is awake. I need to turn that off. That's the line AC, and you're going to have to go digging for a bit more information because they don't give you 2 points at this stage. So you're going to have to hunt and then determine the equation of AC. Okay, so let's see. It's a quadrilateral and the diagonals are perpendicular, which means there's some special information about diagonals that are perpendicular at T. The equation of BTD, so let's use the yellow, the equation of BTD is given by this. But that's sneaky, because if these guys are in relationship, maybe not sneaky, if you know the yellow, you can work out the green because of the relationship between these two. What is the relationship between perpendicular lines? I want to hear someone's voice or see it in the chat. I need to know that you know this. What is the relationship between perpendicular lines? I should have like one of those virtual buzzers, you know, where it goes do, 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 or like I can give you a real like thing when the answers come through. I need to like work on my sound effects, I think. Okay, so what are, you get like a proper clap from me if you can share what the relationship between perpendicular lines are. And for those of us who are waiting, remember 3.1, 3.2, and 3.3. Okay, so I'll give you 30 more seconds. There's a wonderful celebration waiting for the person who gets this. We know that parallel lines have equal gradients. Now, that is not true for perpendicular lines, but what is that relationship? What do we think the relationship is? Okay, so if lines are perpendicular, if we multiply them together, so we'll call them M1 times M2, we get -1. Another way of saying this is if you've got the 1 M1, it's going to be -1 over M2. So to see this visually, if you've got a gradient of 3, a line that's perpendicular to that will have a gradient of -1 over 3. So you just flip them over and change the sign. So let's see if this can help us. So in this question, the yellow is holding secrets, but the secrets are not clear because it's not in standard form. So I'm going to move things around and I'm going to get 2y equals -x plus 18. And then I'm going to divide both sides by 2 and I get that. Okay, now hiding in that is the gradient. Okay. I don't know where I'm going with these. Okay, that's probably a bit too dark. But hiding inside that is the gradient. So you now have the information. The gradient of the yellow one is -1/2. So you know the gradient of this one is -0.5. Now that makes sense. Can you see it sloping down? That means the gradient of this one is going to be +2. And so your answer for this is +2. Now for the next bit, 3.2, determine the equation of the line AC. Well, like we said, we've got the answer to 1. So M is 2. We're just going to do some working out now. So we're going to go y equals 2x plus c. And I just need to know what the c is. And the point A is on this line. So we're going to use -2, -5. I'm going to move my Zoom people to the top. Now, how do we use these? We sub them into the equation. So we go -5 -5 equals 2 times -2 plus c. Try and avoid silly mistakes. Equals -4 plus c. If I add 4 to both sides, I'm going to get -1 is c. And so the equation of my line is y equals 2x minus 1. And if I look at the green line, that looks reasonable. I can see it's going below the line there. Okay, then 3.3 is the last one I'm going to do on this. Coordinates of t. So what are special about the coordinates of t? So is there anything else? Okay, so the question actually says AB is 15 units. So AB, that's for later. So that's AB is 15. How are we going to work this out? I think this is the intersection point of this line over here, the one that we've just worked out the equation to, and this line over here. Now, worst case scenario, we could use the equation that we've just worked out, y equals 2x minus 1 over here, and this equation, y equals, oh, we've already got that. Oh, we can also use the other one we've got, which is this one over here. And what we can do is we can solve them simultaneously by making them equal to each other. But that's a lot of work for 3 marks. So part of me thinks that creation of BD, yeah, let's just have a quick look. For time, I'll bring up the answers. Let's have a look. 3.3, no, that's the other one. Oh no, they do use, okay, they do use simultaneous equations, but they don't take too long. So basically what happens, excuse my graffiti, what we're going to do is we basically take those 2 straight lines and we make them equal to each other. And then we solve for the x, and then we put it back into one of the originals and we solve for the y. And that's going to give us the t. Okay, now on the Watobe app, you can practice by doing other old paper questions, but I would really advise you, it's not that you shouldn't carry on working on these, you should, but you should make sure at a minimum you understand these types of questions. Okay. Give me a thumbs up if you're finding this helpful and the general pace helpful. Give me a thumbs down if you want me to, if you're not finding the general pace helpful. Because I'm going to move to trigonometry now. And I want to, yeah. Okay. And if you aren't finding it helpful, tell me in the chat what you would find helpful. Because I can speed up, I can slow down. It's just a matter of, I know that I don't want to go faster than is helpful. Okay, so like I said earlier in the lesson, if we look at the paper, we're going to focus our attention today around analytical geometry and trigonometry, right? Because these are the bulk of paper 2 marks. And within that, we are going to focus our attention on knowledge and routine procedures, because that is a good strategy before we move on to the complex procedures and the problem solving. So I'm going to do a warm-up where I can just check your basic knowledge. So for this question, it's a multiple choice question, and I want you to answer in the chat, basically, what is the correct ratio for the cos of C? We're now living in the land of right-angled triangles and triangles all together, and the study of something called trigonometry, which often goes together with this. But to show me your knowledge, you are going to vote in the chat. And I'm going to get a sip of water because my voice is... Okay, I'm waiting for some answers in the chat. I see one answer's come through so far. So important ideas in trigonometry are the hypotenuse and then what we would call the reference angle. In this case, because the angle is the angle C, and this is what's sneaky, the angle C is the reference angle, which means that is the opposite. And this one over here is what's called the adjacent. And I might have caught some of you with that. So when you now work out what is the cos of C, for cos, you need A over H. And so you're going to get, so let's just make sure, even for me, my brain wants to make A the reference angle. So C, that's opposite, that's adjacent. For cos of C, it's A over H. So it's going to be 40 over 41, which would be B. And let's just check. We can even check. I've got the answers here because I know that was a sneaky one. I might have caught some of you. Yes, 40 over 41. So just in case you were wondering, wow, what's going on here? Notice how I said the cos of C. So H is fixed in trigonometry. H is always opposite the right angle, right? But when we talk about a reference or an angle in a triangle, we have to nominate one of the two other ones in the triangle. And if C is involved, the thing opposite C is the O, and then the other one is the A. So that's why when we go to cos is A over H, we then go to A is 40 over 41. Okay, that was a sneaky one, wasn't it? You see, it shows you how you have to have your basic knowledge in place. Okay, let us go. This is something like a good multiple choice question. Hey, it's really helpful as a teaching tool. Let me just move these guys out the way because that's for another. Oh, what am I doing? Let's make this disappear. I feel like my multitasking is improving, but it still has a little way to go. Okay, I want you to write this. Basically what it's saying, I know the print isn't great. Write the sine of 62, which is a trig thing, in terms of cos. And that's A, B, C, and D. That's your options. Okay. I'll make these smaller. And get rid of some of the other bits. So write the sine of 60 in terms of cos. Now, just to remind you, we do something called the reduction formula. And if you're reducing something off horizontal, there's one way of doing it. And if you're reducing something with the nearest vertical, there's another way of doing it. And you may remember something called the cast diagram from class. And this tells you where everything is positive here, sine is positive here, but everything else is negative, and so on. So that's the section maybe that we're kind of thinking of. In this case, you want to change it from a sine to a cos. Now, the way to change the ratio is to reduce it using the nearest vertical if you want to change to its co-ratio. So literally sine is related to cosine, which is cos. The long and short of it is I want you to use the vertical. Okay, so I see some answers coming through. I'll give you a little bit more time. Okay. So this is what you always do. The sine of 62 is in quadrant number 1. Okay, 62 is in this angle. So you know in the very end, your final answer has to still be positive. But you ask yourself, how far away is this? If this is 62, how far away is it from the nearest vertical? And I think the nearest vertical, so if I add 8, I get to 70, then I get, this is 28 degrees away. So we can reduce this to 28, but we can't just call it sine of 28 because it's not the same. You can try it on your calculator. But we can reduce it to the cos of 28. And I want you guys to put that in your calculator quickly. See what you get. I've got mine here. Maybe I can even focus. So if I type the sine of 62, I get 0.88. Okay, it's mirrored reversed, so I don't, but I get that. If I type cos 28, what do I get? I get exactly the same thing, confirming that it's equivalent. And so is there an option for that? It's A. Okay. Oh, well done, Asamakli. Well done. Okay, now I want you to do 2 of these. We're going to speed things up a little bit. I want you to, let's just increase these. These are 2 trig type questions from the knowledge section of trig. The one you have to solve for x, the other one you have to find what is the reference angle. And so we'll call this question, let's just call this question 5. And then we'll call this question 6. I'll give you some time for this because, again, these are important. They're the basics or the fundamental knowledge of trig. My Bluetooth is not working for my tablet. I should have plugged it in. So I want you to try and answer question 5 and 6. The one you have to find what x is. The other one you have to find what's called the reference angle or the reduced angle. Can you guys see okay? Just give me a thumbs up if you can see the questions okay. Okay, you can see the questions, all right. I have such a massive monitor, it's hard to know exactly how big it looks on your screen. Okay, great. So solve for x. So we actually have to build our own little trig equation in number 5. And we've given 2 sides. So this is the hypotenuse. Now remember, the x is what we're interested in. Okay. Now, if we're interested in the x, I would imagine making this the O and that the A would be a good idea. So what trig is involved here? Well, we need something that involves A and H. So I think we can say the cos of x. Actually, let me plug this in because I think the tablet is being wonky. So the cos of let's see if this is a bit better. So that's much better. So the cos of x is equal to what? So the cos of x, is equal to a, so 10 root 2 over 20. And so now we want to find what that thing is. But now we need to realize that we need to use what's called inverse cos. And so we go inverse cos of 10 root 2 over 20. And so you should get, in fact, I'm going to cheat and use my answer here. No, that's not the right. Obviously, I've made it disappear. Let's see if this is the right one. Oh, okay, I'll just work it out with my calculator. So, and actually we can make this a bit easier. That would just be over 2 because 10 goes in there once. So we go shift cos fraction, root 2 divided by 2, and we get 45 degrees, which I think is what everyone got, which is great. Fantastic. Well done, everyone. So that's all good. And then what's the reference angle? Well, for the reference angle of 315, the way I think about it is 315's angle goes all the way to here and makes that triangle. And then we ask ourselves, okay, well, how far away is 315 from the nearest horizontal? It's going to be 45 degrees, okay? But because we're using the horizontal, when we reduce this angle, we must use the, oh, it doesn't even ask for, it just asks for, okay. So the reference angle is going to be 45 degrees. Whether it's positive or negative will depend on like the cast diagram, but that's basically it. Okay, let me look at my time because I want to get to the exams. Okay, we are. Okay, we're going to leave that out for now. So if we look at more trig, general trig, okay. So this is a typical exam question. We're only going to actually do one of them now. We'll carry on in the next lesson. But I do want to point out the difference between knowledge and routine procedures and then where you should focus your attention. And then we'll do one of these or maybe two of them to finish with today. This first question is definitely a routine procedure question, routine procedure, because you have to take these expressions and use what's called the reduction formula. Now, in some cases, you will use the reduction formula like this one, you'll reduce off the horizontal. In this one, you'll reduce off the horizontal. This one doesn't need reducing at all. This one can be reduced off the vertical. So I want you to try and do that now. It's 6 marks that you want to bank. And I want to see if you can get the answer, and then I will come along and then show you the answer. So you want 6 marks in the bag. Can you do this routine procedures question? Using the knowledge from the questions we've done today already. And when you're done, you can put it in the chat. And for those who are like on fire, quickly, you could even have a go at 5.2. So just to show you how teachers mark this, basically there would be a mark for this, a mark for this, a mark for that, probably a mark for simplifying those things over there. So that the first bit's really just a whole bunch of smaller questions. So let's put 1, 2, and then we can't really reduce those first bits. They're already there, and then there. So the sign of 90 minus x is actually just going to be the cos of x. The cos of 180 plus x, so 180 plus x is in that quadrant. Now we know that cos is going to be negative in that quadrant, and so we're going to get negative cos x. The next bits are actually already we don't really need to reduce anything. So we're going to say, look, that's already a tan x. That is already a cos x. And then a sine of 100. Okay, the next one, the last one, I'll show you how I do it. I say, look, actually there is a minus 180 in this thing. So there's minus 180. It actually goes the opposite direction. If you've got negative angles, it goes clockwise. If it's positive angles, it goes anti-clockwise. So this for me is the angle minus 180. Now, if I go plus x, I'm going with a positive angle in that direction. So I know that I'm x away from the nearest horizontal. But the important question is sine positive or negative in that quadrant that I'm in? And in this quadrant, sine is negative, which means that when I write my final thing here, it's going to be negative sine x. Okay, that's what we call the reduction formula. And I promise you, you want to invest some time in studying that. If you haven't understood it, practice that from all exams from the Watobe app. Okay, so let's see how we would finish this off. So now what we have is this over here is looking kind of okay, but this is a bit of a mess. So this bit over here can just become minus cos squared x. Okay. But this one over here, this I need to break down. And there's something called the quotient identity. And that's that tan x can be written as sine x over cos x. And now we've got this cos x here. And then we've got this minus sine x here. Let's get a different color. Cos x over cos x is 1. And so now I'm left with minus cos squared x minus sine squared x, because this sine x over here is being multiplied by this minus sine x. Now you may say, oh my goodness, now what is this? And this is where it helps to know another identity called the square identity. So I can rewrite this. If I take out a negative, I can write this as cos squared x plus sine squared x. Think about this. If you multiply minus times this, I get minus cos squared x. Minus times this gives me minus that. And the identity in trig is that cos squared x plus sine squared x is 1, so you get minus 1. Okay, how are we doing on time? So that is the first question. Now, the second question probably involves something called special triangles. And I'm actually going to zoom in a little bit so you can see this question. I want to finish with this, and then we'll do the admin. But let's just see if we can squeeze in this question here. Okay, 5.2. And again, I want you to use the reduction formula, but note it says without a calculator. And then we'll finish off today, and we'll continue with a bit more trig in the next lesson. And then I will also bring in Euclidean geometry. I'm not going to do data because I did a whole series on data that's already on YouTube that you can go back and look if you need a crash course for exams. Okay. So let's finish strongly today with 5.2. Oh, okay. One bit of technique. This is a prove question, which means that you work with the left-hand side and the right-hand side independently. So what I would do is I would start by looking at the more complicated one and try and make it look exactly like the one on the right-hand side. So how would I do that? I just say left-hand side equals this whole thing over here. And I work with the left-hand side until I can say at the end, it's equal to the right-hand side, which is this one over there. So I just want you to try and use the reduction formula for these first ones over here. See if you can, it's 5 little questions. Alzana, is it okay if we just run 2 minutes over?
No problem, Peter.
So ask yourself, what quadrant is sine 315 in, and what does it break down to? So I think it's going to be negative sine 45. what is the tan of 210 going to reduce to? Well, where is that going to be? So tan of 210 is going to be in this quadrant. And in this quadrant, tan is positive, so that's good news. So it's going to be the tan of 30. So I handled those two. The sine of 190 is probably going to be negative sine 10. And then what is the bottom part going to be? Cos of 100. I would probably use the vertical for that. So if I'm dealing with the cos of 100, it's going to be here. Now, this is a bit of judgment, but basically I'm going to say the cos of 100, C-A-S-T. Okay, so when I reduce this, this is going to be negative because the cos of 100 is in the quadrant that's negative. And it's going to be, if it's changing from cos to sine, it's going to be negative sine 10, which is really great news. And then the last reduction is the sine of 120. The sine of 120 is going to be past here. You could make it a couple of different things. I'm going to make it off the vertical. It's going to be the cos of 30. Okay. So those are the main reductions. I'm going to show you the answers because we've run out of time. Let me just, and then I'll talk you through it. And then we're going to finish the lesson with a poll. And then Alzan will also have a quick chat with us about any other important things. So if you look at the perfect answer, what you'll notice is that there's all the marks for doing this. And then all we do is we use what's called special triangles. Now, the special triangles, you actually kind of look, okay, I'm not going to go into them now, but basically you can substitute from these into here, and then that's how you would get your final answer. Okay, and these are guaranteed to be in your exams. Every exam paper that I've ever seen for grade 11s has these types of questions to start with. Okay, give me a brief feel about how you felt about the lesson. I know there's not a lot of room for like rating or whatever, but just thumbs up, thumbs down. How are you feeling? If you're feeling confused or we need to go faster or slower, let me know in the chat. I just want a feeling for how the group is doing. I don't have your facial muscles to see like I would in the normal class. Alzan, could I ask you to, Caleb's like, not so sure. Could you go to poll and then, is it possible for you to send out the poll, not the do now, but the other one? Could you click it?
There's a study setup poll.
Yes.
With 5 questions.
Yeah, if you could just send them out to them. I don't know if I'm trying to be too greedy, but I'd love to know if they can, and give us a thumbs up if you can see the poll. And I promise I will let you guys go soon.
Mm-hmm. So I launched it.
Perfect.
Can you guys see anything?
Oh, I can even answer it myself. Huh, awesome. It's nice being on the other side. So we'll just give them.
Awesome. So we can give you a few seconds. Yeah. And then while they're busy with this, Peter, should I show them on the app? I saw that you said revision work is one of the past papers. And yeah, should I just show them which paper exactly? Is there specific paper?
So paper 2. So it's paper 2. And today's focus has been around trigonometry and what's called analytical geometry. But generally, paper 2 will always have questions on that. So I would recommend practicing again this evening using the same ideas that we've learned about, because you start to see patterns that the exams are set with a very similar structure. So yeah, I think that's a good idea.
You can let me know if you are done with your screen, then I can maybe share my screen quickly.
Yes,
That's okay.
Okay, so I'm done with my screen. If you could just take a screenshot, Elzan, if you can, or of the results when they come in, because or something,
Yes.
because I don't think I will see them. But yeah, and over to you.
Sure
Thank you for your patience.
Sure thing. So I've got, seems like 2 out of the 5 has participated, 3 learners. Awesome. Okay. And then we have a Zoom user here. Zoom user, could you please identify yourself? Love to know what your name is.
You should just.
Zoom user just hopped off. Caleb, you've got a hand up. Please feel free to ask if you have a question.
Maybe Caleb was identifying himself as the Zoom user.
Yeah. Hello. Yes, I've been
Hello.
using Zoom. I've been using Zoom on my phone. I actually had trouble logging in on my PC, but I enjoyed the lesson today.
Thank you.
I'm really not. I'm really like there is stuff that I am struggling with in maths because we didn't actually like have really a lot of maths classes in grade
Okay.
10. It was like only term 1, and the rest of the terms we never actually went to school because of lockdown.
Yeah.
So yeah, it is something that I need to get used to, and I definitely need to put some work in because I can my maths marks isn't really that good, which good is very bad actually, which isn't really that good, which is very bad. But yeah, I don't know.
I've got a question for you. Are you finding the environment somewhat helpful, or do you think you would need to go slower or faster? Like, what is your feeling of the lesson when you're watching?
So sorry, can you just repeat that? My mom entered my room. Can you just repeat that? Oh,
So
the environment. I'm more. The environment is that like I'm a person that doesn't want to ask a dumb question, which I know there's no thing as dumb questions, but there's certain things that I'm actually really confused about in certain occasions. Like today's session was nice because I understood in a way. I understood in a way, but me generally as a person in maths, I like to be it would be comfortable for me to actually be one-on-one with a tutor so that I don't like I like to have a connection when I'm busy doing when it comes to maths so that I can understand, and that maybe the tutor can maybe help me much and explain to me in a much better sense, or
Okay. No, I know what you mean.
revise the word you know what I mean.
What I would suggest is keep sending in your suggestions, because the thing about this is that it's a very flexible space. And so it's always helpful to give your feedback so that we kind of know where what helps and what doesn't help the students. I know, Elzan, you were going to say anything, or?
No, thank you so much, Caleb, for sharing that. I think it's awesome to get some feedback, like Peter said now. And yeah, like you said, there's no question like a dumb question. So if you struggle to understand anything, any of you guys just continue to ask, continue to practice. So I'm going to end this poll quickly, and then I'll show you where you can find this past paper. Caleb, is it your first time on this live class today?
No, it is not. It's my 4th time on the
Your
live.
4th time. I wanted to say, I feel like I saw your name previously.
No.
I just wanted to make sure.
It's the first time
Okay.
we're hearing his. It's so nice to hear the student behind the icon. It really gives you a better
Exactly.
sense.
Exactly. So let me just show you here on Calibri is, so when you go into skills, you'll find Watobe library. Then in here, you will find exam papers, mathematics, and we are in grade 11, obviously.
Yeah.
And then here's a few papers from like the second paper. from
Yeah.
2017, 2018.
So I was doing the 2017 exemplar paper today.
2017. Perfect. So,
Yeah. That was what I was.
Caleb, Ashley, this is the papers that you guys can go and revise, work on it. Yeah, and there's a memo as well if you need the answers afterwards.
Perfect.
Okay, so that's all from our side. Then we will see you again on Thursday. Take care of yourselves. Yeah, keep up the hard work, and thanks for joining in again today.
Yeah, that was good. Cheers,
Okay,
everyone.
thank you. Enjoy the evening further.
Bye. You too, Caleb. Cheers. Bye, Peter.
Now, Elzon, could I just ask you before you can turn the live stream off?
Yes.
If you could just take a screenshot if you can or something of the results and just put it in the Slack or whatever it is, or you can even send it to me on email or whatever. I just want to get a sense of those, if there are any things.
Yes, of course.
Cool.
So I'll put it on Slack now on the live stream, on the
Yeah.
live classes.
Yeah.
Okay.
Thanks, Elzon.
Awesome. Thanks, Peter. Take care. Hey.
Ciao.
Bye-bye.